So I just gave you an overview of the Reactive Streams API. And it turns out, for a variety of reasons, that's useful in a limited sense, but we need a lot more. And so we're going to talk now about some of the popular implementations of said API and all the cool things that they add above and beyond what comes out of the box from Java 9. So first and foremost, the Java Flow API isn't very useful by itself. And I was looking around for a meme that summarized useless things. So here's a good example of a useless thing, a key that has a flat end. Not very useful because you put it in the lock, you can't turn the key. A fork that has a chain on the handle. You're not going to be very, you have to like grab the fork and eat it that way. A wine glass that when you drink dribbles the wine down the front of your shirt or your dress or whatever you're wearing, right? Not very useful either. And the Java Flow API. So we put that up there with a set of useless things. So therefore, it does one thing. It provides an interoperable foundation that various reactive programming frameworks like RxJava and Project Reactor use. And because of that, it's relatively straightforward to write code that mixes between RxJava and Project Reactor if you want to. It's not very common, but it's doable. And so that's really the only purpose that this API serves. So we need a heck of a lot more stuff. Why do we need a heck of a lot more stuff? Because what we really want to be able to do in practice is have events come in from some event source, like a Twitter feed or whatever, and we want to be able to move the events through a sequence of operators that transform or filter the events in various ways. The thing that should pop into your mind is like a Java stream, where you have operators like filter and map and flat map and sorted and drop while and take while and so on and so forth. And we want to be able to do things to the events as they flow through. So we want a pipeline or an assembly line of transforming or filtering operators that will do things on the events as they flow through the stream from the publisher, which is the source, to the supplier, to the subscriber, which is the sink. So that's why we have all this other stuff to do all those operations. And it looks pretty much like this. This should be, again, very familiar. The analogy we used when we talked about Java streams was a water filtration system where it flows through different filters to remove impurities of water. And over here, you can see that the streams work very much the same kind of way. Now, there are two primary Java-based reactive streams frameworks we're going to talk about, and we're going to focus pretty much exclusively on one of them. But I want you to be at least aware that there's more than one and what they provide. And the two we're going to talk about are RxJava and Project Reactor. For those of you who took my class last semester, the 253 class, we focused on RxJava. This time we're going to talk about Project Reactor. And the reason for that is that Project Reactor is baked into Spring WebFlux, which is this web-based programming environment that takes the concept of Spring Web MVC, which we've been using, and then adds reactive types to it, which is kind of cool. So here are the 5 key classes in RxJava: completable, maybe, single, observable, and flowable. I'll talk briefly about each of them. And then here are the 2 classes that Project Reactor has, mono and flux. And you'll see that mono kind of plays the role of completable, maybe, and single, and flux plays the role of observable and flowable. So again, anybody who took the class last semester, that's kind of what we're doing. Let's talk about mono, because we're going to spend a lot of time on mono. You'll get a chance to play around with mono. It basically is a reactive type that will either complete successfully or fail, and therefore may or may not emit a single value. It's very much like an asynchronous variant of the optional class that came in Java, where you can either get a result or not. Here's a very simple example. We're going to take a fraction and turn it into a mono, and then we're going to convert the fraction to a mixed string and then print the result. And that's done reactively. OK, so the other main abstraction in Project Reactor is a flux, which emits an indefinite number of events, namely 0 to n, as many as you want, infinite, which may or may not successfully complete or may fail. And the other thing that a flux does is support something called back pressure, which allows the slower subscribers, consumers, and so on to tell faster publishers or sources of events, please stop, you're sending things too fast. And here's a very simple example where we're going to create a bunch of values here, and then we're going to pass them up and do, this is a generator that'll generate a bunch of events using some kind of processing operation that's passed in as a supplier. It'll count number of these things. I also should mention very briefly, because we're going to talk about it a bit, there's also a parallel flux, which does the computations in parallel. So a parallel flux is a bit like a parallel stream. And now for the RxJava stuff, I'm not going to spend much time on this. There's something called a single, which is kind of like a mono. And you can do much the same thing with a single you could do with a mono. There's something called an observable, which is like a flux, but it does not support back pressure. And you can have it emit events, but there's no back pressure enabled. There's a flowable, which is like a flux in that it does support back pressure. And so you can do back pressure kinds of things with flowables. And there's also a parallel flowable, which is like a parallel flux, which is like a parallel stream. And then finally, there's two other things, a completable and a maybe. And they're kind of weird, and you can see sort of why they left them out of Project Reactor. But a completable basically can either succeed or fail, but it won't emit any values. It just is like, I'm done, and I either succeeded or failed. And a maybe may or may not succeed. That's also a very kind of a questionable operation. It gets used in a handful of places where you might not actually have any values in your stream, so you don't know whether you're going to emit a result, so maybe you'll emit a result. So anyway, I did this for completeness, but please be aware we're going to focus pretty much exclusively on monos and fluxes, with a great emphasis on fluxes and somewhat of an emphasis on parallel fluxes. So that's the overview of the Reactive Streams API.